Hello everyone, and welcome to our webinar. So my name is Bartosz Górski.
And my name is Szymon Krasuski.
And together we want to tell you more about the 5G rollouts and how you can manage your service lifecycle by using Kubernetes and CNI plugins. So without further ado, let's start. So during our presentation today, we will first give you some brief overview about the current 5G deployments and rollouts, and what are the models that are used right now, and what is the target model that we want to reach, and how you can leverage the cloud-native functions to have really 5G core network with the full performance it can provide. And after this brief overview, we'll move more to the technical side and how you can integrate the containers platform into your infrastructure and how to use CNI for that. We'll also show you an example of the Tungsten Fabric and how this integration works there. Then we'll move to a more complex use case as using different SDNs by leveraging Maltus. And then we also will show you a few use cases, how you can use Kubernetes and CNIs to have different integrations. And after these use cases, we'll move to the Q&A session. Also, if you want to ask any questions during the presentation, there will be a link to Slido in the YouTube comment section, so you can post your question there and we'll answer it at the end of the presentation. So maybe to start, so recently there was quite a lot of rumors and also the news about the 5G networks and the benefits that this fifth generation of the wireless networks will provide to the end users. It will improve the latency, bandwidth, and also the capacity of how many devices the network will be able to handle. But when it comes to 5G, it's also important to know that there are different levels of the band that are used for that. There is low band, mid band, and ultra band, and high-speed band. And this, the full benefits of the 5G network will be available to us with this higher frequency. Currently, those benefits will also add a new capabilities to the different industries. The mobile networks and smartphones look able to connect the wearable devices, self-driving cars, and also more capabilities for the industry 4.0, also with smart cities and others. But it's important to remember that the 5G is not only the radio part, but also the core network behind it. And recently we saw commercial rollouts of 5G offerings within the different providers, and you probably were able to see the 5G icon on your phone. But is it really the ultra high band network that was promised to us? To tell about more about the current deployment models for the 5G networks, is that right now most of the wireless connectivity and the infrastructure was added to the existing infrastructure that we have for the 4G. And the new standard for wireless communication, which is called 5G NR, which stands for the new radio, is still leveraging the core network that was used for the previous generation of the networks, which is called EPC, which stands for Extended Packet Core. And it's not allowing us to benefit from all of the benefits that 5G can give us. It still might be similar to the performance in the different connectivity zones with a similar performance of the 4G. And this is what we call not standalone deployment. So just separate radio and access network and still leveraging the core from the previous infrastructure. To be able to open and leverage the full capacity of the 5G can give us, We will need also the new core network that will use the recent innovation within the networking industry to be able to provide the high-speed networking. And also the 5G will not cover everything. With the new benefits and the lower frequency, we will have the trade-off between the high speed and also the coverage. So we will still use the 4G for the more wide area areas to be able to connect to the network. So still we'll need to have the support both for the 4G and also for the 5G in more dense areas like big cities, on stadiums. So still we'll need a dual mode to be able to support both of them. So what will be really needed to have this 5G core? What are the challenges that we will need to have this 5G core? So the first thing will be the virtualization part of the different services and lifecycle management of the services. We'll move more of the functionalities and network function to the software, and we will need to be able to manage the deployment, monitoring, and also termination of the services. And this will be a challenge to be able to do it. And with the more spread and the bigger networks, we'll also need an end-to-end automation and make sure that we can orchestrate everything from the one place and improve the security by the central policy management. Also with a lot of different technologies and smaller parts to make sure that we can keep up with the technology growth. We will need also the standards for different components to make sure that the more companies and more vendors, not only the large one but also the smaller one, will be able to contribute to this technology. And as it comes with all of the ongoing services, together with the changing of this core network, we'll need to provide a service continuity. So the migration part will be also needed to make sure that we can support both infrastructures at the same time. So to be able to really provide a 5G core network that will be based on the cloud technologies, we'll need a small shift in the way how we will provide the different services. Right now, we will move away from like the monolithic architecture more to the service-based functions to make sure that we can have it smaller pieces that will be managed easier and will improve the time we need to deploy the different services. We will also use the recent technologies in SDN to split the brain from the muscles to make sure that we can manage from the central place the hardware that will be doing the heavy-duty tasks. And also, the previous network was mostly based on the virtualized network functions using the VMs. But we really want to have the really slow delay in the network. We will need a faster way to bring up services. And this is where the containerization will take a huge part to make sure that instead of VNFs, we can use the CNFs. And we will need to integrate different containerization platforms within our networks. And then with all of those new technologies and the virtualization part and this central part to manage all of those networks, we'll also need a way to better operate the networks and spot any problems or defects sooner and, as far as possible, fix them in the automatic way. This is where the AIOps will help us to analyze the data that we will have and maybe propose the solutions or maybe even execute those solutions automatically. Maybe even predict some of the failures before they will happen to make sure that we can match different SLAs. And to sum up, so the benefits from the business perspective, the cloud native will give us a more flexibility when it comes to delivering services. We won't be based or dependent to the underlying hardware. with providing more standards and moving more of the intelligence to the software, we'll be able to use the white boxes and deliver the services in more flexible way. It will also improve the speed, but we are not talking here about the speed or the performance of the whole network, because this will be done by the offloading some of the heavy-duty tasks to the programmable hardware or the smart NICs. But here we are talking more about the upgrades of the network, the development of the services, introducing the DevOps approach to be able to introduce CI and CD and do a smaller updates, and microservices infrastructure will help us to do it and avoid the risk of doing a big changes to the network and affecting a lot of users. Also, with the more centralization part, we'll have one way to have the visibility of the whole network and see what is really going under, what are the different metrics, and orchestrate the whole network from the one central place and gather the metrics used for the different AIOps models to be able to operate in the better way. And also there is a cost part. So virtualization is promising us that we'll be able to better utilize the underlying infrastructure and save some money on it. But so for sure one of the possible ways, but also with the speed, that cost saving won't be only on the utilization of the network, but also on onboarding the potential clients and improving the time to market that we will have. And from the brief overview of the 5G and the cloud native networks benefits, right now we will move more to the technical part and how we can really integrate the containerization platforms to your infrastructure to make sure that this transition can happen. And I will pass the voice to Shimon.
Thank you. Okay, so maybe coming to more technical side of this problem. So probably you know this infrastructure from a network where you have some services, you have some bare metal servers, you have, for example, OpenStack cluster of virtual machines, and this is the network that you may have today. And when you have a lot of services, you may meet a problem that you want to allow some traffic between, for example, two bare metal servers. You want to deny some traffic, for example, from bare metal server to OpenStack cluster, or you want to reroute some traffic because you have a monitoring service that gathers all the logs, then analyzed by your SOC department. So generally you may have engineers that configure the routers, switches, firewalls, other networking devices. This may be as well as physical devices, as well as virtualized devices somewhere in the cloud, or somewhere virtualized in OpenStack cluster, for example. But then you decide one day that you want to change the rules that are present in your network. You want, for example, to allow more traffic or deny more traffic or do something else. Then you need to hire engineers that will reconfigure the routers, switches, other devices, and think about the huge infrastructure when you have a lot of physical devices, so it means a lot of work to do that. Also, when you may want, for example, to apply some rules only during the nighttime or during the daytime, so in some schedules, then you have a problem because each time someone has to change that to meet the requirements of your network. So that may generate a lot of problems, because even if you mess up something with configuration in one router, then the whole network is down and the rules do not work properly as you wanted it to work. So you may use the SDN, software-defined networking. So software-defined networking gives you a possibility to have a central point like SDN controller, which allows you to specify the rules that, okay, I want, for example, to allow the traffic or deny the traffic, and then SDN does everything for you. So you don't have to configure each router manually, each switch manually, and apply the configuration. You may do that just from the single point in your infrastructure, and then you have the whole network configured. If you think about the SDN controller problem that it may be a single point of failure, consider that it has usually a high availability mode, so there are some replicas, so it's the same as with other services that should work all the time no matter what happens. Okay, and maybe looking on the layers of the software-defined networking. So you have a so-called underlay network. So these are your routers, switches, physical devices, the infrastructure layer, and at top of that you apply the control layer of SDN. So it means that your SDN is communicating with these devices via API, or even if you have some fancy, low, not so well-known router, you may even communicate via CLI. When your SDN supports that, you may configure the route from the SDN. But when you're an end user, you only think about endpoint 1, endpoint 2, and I want to allow or deny the traffic between them. So I don't think about configuring routers. So there's an application layer that allows you to specify only rules, high-level rules, and then SDN allows you to automatically configure routers to meet the requirements that you gave in these rules to allow, deny, reroute traffic. And the new network created by the SDN, the one that you see with the rules you specified, is called the overlay network. Okay, and when we do a deep dive into the SDN architecture, usually we start with SDN application. It may be the UI, it may be a CLI, or in fact, usually it's driving the SDN normal interface, so some API. So when you have an API, you may even implement it with your custom application, custom service that you want to use to, I don't know, to automate all the SDNs that are on the market, or control all the SDNs on the market, or do anything that suits your business. And then the high-level specified rule goes to SDN controller, which computes what should be done in the underlying network, so in physical network, to meet the requirements gave by the user. And then by the SDN control to data plane interface, it sends rules or configurations that should be applied to physical devices. An SDN data path are the components that sit at top of these physical devices and interact with them to apply this configuration. But then there are the new trends. Cloud computing is more and more popular. Also, we have Kubernetes, so we have containerized applications, which are not the standard virtual machines or servers. We have Kubernetes that gives IP address and provide networking for these containers. So that's the problem, that it does not work as it used to be with OpenStack and bare metal servers. So, taking into consideration the SDN that personally I work a lot with, I'm also a technical steering committee member of Tungsten Fabric. So Tungsten Fabric is an example of the SDN, which implements the architecture that I showed you in a few slides ago. And in fact, when you have such an SDN, it does not care whether this is the virtual machine, container, or bare metal server, because it has API. And as long as API is fulfilled and the endpoint, like VM or VMS container, may communicate with this API, it may be controlled with the SDN. So you don't have to only work in the range of supported devices, supported solutions. You may as well fulfill the API with your custom solution. So you may build a third-party solution using the SDN. And this is how it is usually with other SDNs on the market. And then, how do we connect with the Kubernetes? So, in order to fulfill the API of the SDN, Kubernetes has something called CNI. This is the Container Networking Interface. So this is the interface used for communication between SDN and Kubernetes. So each time you create the container or pod, which is usually the namespace in Kubernetes that may contain one or more containers, you'll receive an IP address from some SDN called by the CNI. And also then when you have a networking between the containers in different namespaces, in different services, the traffic is controlled by the SDN controller. So this is the part that controls and fulfills the API of the SDN. As far as I remember, Kubernetes takes only 2 files to configure the SDN that you want to use. SDN may be somewhere outside your infrastructure. As long as it has an IP address and authentication to connect to this SDN controller, you may connect to it. You may also set up an SDN controller inside the Kubernetes cluster and also use it as a CNI to drive the traffic and networking in the Kubernetes cluster. Okay, and when you think about such a solution, and you may easily come up to an idea to use multiple Kubernetes clusters and connect each of them with SDN controller to make a single infrastructure of Kubernetes clusters connected with each other and driven with the same controller. And then, using that idea, you may use a Google Cloud or AWS and any other cloud provider to build a pretty easy multi-cloud solution. So using the CNI and SDN, multi-cloud is just one step apart from you. Okay, and something more fancy is Multus. Multus is a tool used for CNIs, because usually when you think about the pod, you have a single interface with a single IP address received from the SDN controller. So in our example from the beginning, we may have SDN controller somewhere in external in our infrastructure, which is external for Kubernetes cluster. So what happens when you're disconnected from the infrastructure? You may have a problem because you have only single CNI driven somewhere outside of the cluster, so all the pods lose the communication. So Multus allows you to have multiple interfaces, multiple CNIs. So for example, you may use Tungsten Fabric's SDN and other SDN to attach 2 interfaces, 2 IP addresses to the pod. So Multus will allow you to call 2 CNIs, and then in your application, your pod specify which interface you want to use for which route, which traffic. Okay, and coming to the use cases, the first use case would be to have a private cloud with, for example, OpenStack cluster, or if you want something more enterprise, the VMware cluster, which will be connected with the containerized services in Kubernetes, or more enterprise solution, OpenShift. So just using configuration from the SDN controller, you may allow communication and specify all the rules between the virtual machines, virtualized services, and containerized services. It's as easy as it seems. Another use case would be to use a hybrid cloud. So here we have a data center again with some virtual machines, here on Enterprise VMware. And you may think about the example that I showed you with multi-cloud to connect via SDNs to cloud-native applications. So, of course, you may use the Azure, ACS, GCP, GKE to connect to native Kubernetes services. But also, you may think about using other cloud-native solutions. For example, Azure has a pretty good machine learning tools. So if you think about using, for example, machine learning in your services, you don't have to buy the new servers with good GPU, because usually we use GPU for machine learning. Think about how to configure that, and what if you only want to run once a year such a machine learning process, then the rest of the year your server is doing nothing, in fact. So you may just call the native machine learning application in Azure, do what you need this one time of the year, and then just shut down the service. Also, you may use the SQL, both on Azure, GCP, also other cloud providers provide SQL database, so to keep the data, and you also don't need to think about the scalability and availability of your database. GCP has a pretty cool BigQuery mechanism where you may sort and look for data in your databases, so you also don't need to implement something by yourself, or you may easily use compute or cloud services, which are in fact cloud virtual machines that allow you to do the same workload that you have in your data center. And the third use case is about the Multus, the nested cloud called here, because we have our infrastructure, as you can see, with bare metal servers somewhere in the infrastructure, and also we have Kubernetes cluster. And let's say that in Kubernetes we have a service that is built with microservices which communicate with each other, and on bare metal server we have, for example, the SQL, and on another bare metal server we have user data, so something which we shouldn't share with the rest of the network. So with the global SDN controller we may connect Kubernetes cluster to the bare metal servers and allow the traffic only between the SQL databases and services in Kubernetes cluster to gather some data and compute it or put some data there, and deny communication with user data server. And in Kubernetes cluster, we may assume that, okay, this is the same service built on microservices, and there's nothing more running there, so we may trust these containers to communicate with each other. So we may add another SDN controller inside the Kubernetes cluster, only for routing the traffic between the containers in the Kubernetes cluster. So that way, when you have a traffic outside of the cluster, you use the global SDN, but when you have traffic inside the Kubernetes cluster, you use the Kubernetes SDN controller. So, assuming that, for example, you lose connection from your Kubernetes cluster to the rest of the infrastructure, you still have a running service which communicates using the SDN. Okay, and these are all the use cases that we have for you today. If you have any other ideas how we may use that, we are welcome to share that with us in comments, or write to us from our website, or write to our mail. And now we have a QA session on the Slido. You may ask on YouTube comments, and we'll tell you more about that and answer your questions.
Thanks, Sean. Okay, I think we have the first question, and the first question is about, will the 5G replace the Wi-Fi? I think this is quite the generic question. Like, my first feeling would be to say that no, it will not replace the Wi-Fi. I think Wi-Fi is mostly used for like the short distance connectivity that you're normally using in your home, which is like your private network, but you still want to have some your own rules and the configuration. 5G is like more the use right now for the public networks and the wider areas, similar like the previous generation, the 4G. But for sure, those are like the two leading standards when it comes to wireless communication, and with the capabilities that 5G will provide, so like the low latency, high bandwidth, maybe it will replace the Wi-Fi in some places, because we know that with the lower bandwidth, with using the operators networks like LTE, sometimes when we are inside a city and we want to use the internet, we are trying to connect to the public Wi-Fi's, which are not the most secure networks and risky. So maybe instead of like using Wi-Fi in, like, I don't know, like a Starbucks or the other coffee shops, and together with the 5G and the infrastructure within the cities or the high dense areas, will really be more effective to use the 5G, to not need to connect to the unknown Wi-Fi's. But I would still say that those two technologies are more comprehensive to each other than like trying to compete with each other. 5G is quite a new concept. It's still under the standardization between different parts, and standardized by different committees, like 3GPP. The virtualization part is by ESDI. So I would say that no, it probably will not replace the Wi-Fi. Wi-Fi will still be used for the having private networks. There is also a concept of the private network with the 5G, but probably they will be first deployed for the enterprises than for home networks. So I would still say that within the next couple of years, the 5G will be more for like the public and enterprises, and the Wi-Fi still will be used more for the smaller deployments. And also with all of the devices we have right now, which have only like the Wi-Fi connection, even if the shift will happen because of some regulations or the general movement, it will take a few years. So I think there is no worry about like getting the Wi-Fi standard anytime soon. Also, recently I think there was a new specification, version 6 for the Wi-Fi, which also have quite a few improvements. So I think like the short answer will be no, but we don't know the future, so we'll see what it will bring in a few years.
Okay, how CNI supports integration with hardware? So when you have a multis tool, you may use it to connect CNIs, but you may as well use it for SRIOV solutions or LibGD solutions, which are working with the hardware to provide networking in Kubernetes. So everything may be done with the multis.
Okay, for the 5G network slicing use case, which one is better, the VRNF or the CNF? So we see that the shift is more to the CNFs, and together with the possibility to have the multiple interfaces for the CNFs, they mostly will be used for the network slicing use cases, and the general difference between the VNFs and the CNFs, that CNFs are more lightweight and we'll be able to bring them faster, and also if we will be able to decouple the multiple functions that were in the VNFs to the CNFs, then we'll be also able to scale a particular part of the network or the services more granularly. So I would say that the VNFs probably is better, but it depends on the use case. But the shift, like of the whole part, is more to the CNFs part, or the CNFs components.
What is the difference between access and network and core network? It's a wide topic. So when we think about the core network, that this is what provides the basic services and spreads the infrastructure that provides the services that we have in our infrastructure. While access network is usually used to access the services, maybe from outside, maybe from some other sub network or sub infrastructure. So it's more secured to core network, and sometimes there's like DMZs, so demilitarized zones in networking, where you have a separation between the network that you may access and services that you may access, and the core network that should not be accessed by someone from the external or only by the trusted services.
I think also when it comes to like the 5G part, for the access and the core networks, also like the well-known concept for the previous generation. Like the core was the backbone of the network, and the access was the simplifying the last mile problem to connect to the given users. But together with the 5G, we mostly, when we're talking about the access networks, we are talking about the radio access network, and this is like specified by the 3GPP organization in the details, but it's mostly the network that connects the mobile devices to the network, and the core part is just for connecting different elements and different elements of the network and multiple of the access networks.
Okay.
Yeah, go ahead.
Okay, thank you. How different is integration of Kubernetes and OpenShift? Okay, that's an interesting question because I worked a lot on that actually. And you may think that Kubernetes and OpenShift is pretty much the same. OpenShift is enterprise solution of the Kubernetes, but in fact OpenShift has built from the ground all the components of the Kubernetes or a Kubernetes-like system, which is an OpenShift. So at the first sight, you may think that OpenShift works in the same way as the Kubernetes, but when you take a deep dive into that, you'll see that some configurations, for example, some configuration map, some services work differently than the Kubernetes, and sometimes when you have a really advanced service which you want to integrate containers, you may have a problem to just take it from the Kubernetes and apply it to OpenShift because of these nuances in these both solutions, both products.
Okay, what can be some security-related challenges with the 5G, so VNF or CNF deployment? So when it comes with to the security, there's a question: what is more secure, running the VM or running the container? And from that perspective, like running the VM is more secure because you have the whole separated system. With, for example, Linux separated kernel, and then like the OS part. With the CNF part, this is something that is shared between the different containers. CNF deployments have there's some kind of trade-off. The lightweight infrastructure, but the more resources are shared between the containers. So there are some challenges regarding the potential breakout of the given container and affecting the other running functions. But also there are challenges for the for the incoming traffic and how to really monitor the traffic between the containers, enforcing the policies. Also making sure that the ingress rules are set up correctly. So I would say that there are still challenges that are not solved for the CNF deployments and will probably require more work in the tools to do it. But there are already some projects that trying to tackle those problems. For example, one of the projects which is called the Kata containers, where they're trying to provide more secure containers deployments. So there are some solutions that trying to tackle this.
Okay, so we don't see any other questions, so maybe let's wait a bit. Maybe someone has some last minute question.
Yeah, in the meantime, if you are interested in any of the use cases or you would like to learn more details about them, feel free to to reach out to us after the webinar. Either you can find us on LinkedIn and write to us there, or just email to our generic contact email address and ask for us, and you should get redirected to us.
Okay, so it seems that there are no other questions. So I think that we may finish here. So thank you for joining us for this webinar. I hope so that you learned something, that we created some curiosity in you for the 5G solutions of the future. And maybe something for your side.
And thank you for your time. Thank you, Shimon.
Okay.
And see you in the future.
Okay, thank you.